In this example, we're going to go ahead and calculate the molecular mass for the sugar ribose. So ribose has the molecular formula C5H10O5. Now, if you recall, the way to calculate molecular weight, you essentially take all of the atoms that are found in that particular molecule and their individual atomic masses and add them all together. So, for example, ribose is made out of carbon. It's made of hydrogen. And lastly, oxygen. Now, carbon has an atomic mass of 12 daltons. An atom of hydrogen has an atomic mass of 1 dalton. And oxygen has an atomic mass of 16 daltons. So if ribose, for example, has the molecular formula C5H10O5, it has 5 carbons, and each carbon has an atomic mass of 12. So we multiply 12 by 5. Now we add to it the masses of all the hydrogens. So ribose has 10 hydrogens, and each one has a mass of 1 dalton. So we multiply 10 times 1. And then lastly, we're going to add to that of all of the atoms of oxygen. So ribose here has 5 oxygen atoms. Each oxygen has a mass of 16 daltons. And we're going to do the math. So 5 times 12 is 60, plus 10 times 1 is 10, plus 5 times 16 is 80. Add that together and you have a molecular mass of 150 daltons for ribose. Now that means, right, so 1 molecule of ribose has a mass of 150 daltons. If you remember from chapter 3 in this case, when we were talking about molecular mass, and we were also starting to talk about molarity, we reviewed the fact that a mole of a particular substance is 6.02 times 10 to the 23rd molecules of that particular substance. And we also talked about how if you know that if you know the molecular mass of a molecule of that substance in daltons, a mole of ribose, or 6.02 times 10 to the 23 molecules, has a mass of 150 grams, right? So essentially what we're doing is we're correlating the mass of 1 molecule in daltons of a substance to the mass of 1 mole of that same substance. Same number, just different unit. Instead of daltons, it's going to be grams. Okay, so let's talk about molarity for a minute. All right, so molarity, if you'll recall, is a measure of concentration. Essentially, it tells you how many moles of a solute you have per liter of solution. So let's say I asked you to make a 1 molar solution of our ribose here. You know that you want to add 1 mole of ribose per liter of solution, right? So a 1 molar solution of ribose would require measuring out 1 mole of ribose, which is 150 grams, and dissolving that in 1 liter of water, for example. Now let me ask you another question. What if instead of a 1 molar solution, I needed a 2 molar solution of ribose? How much ribose would I measure out? Well, if 1 mole has a mass of 150 grams, then you would simply want double that, right? So 2 times 50 grams per 1 liter. So that would be 300 grams of ribose per liter of solution.